Hey Team Physics, I am in New Haven at a coffee shop recording this screencast, so if I get interrupted for any reason or there are weird noises, that is why. Okay, so welcome to your next screencast. We are going to be starting our analysis of momentum, our next unit. And today we're going to be talking about two pretty important questions. The first one is, what does it mean to have momentum? Okay, so I've written that question down here. What does it mean to have momentum? And the second question is, what is impulse and what is impact? Okay, so I've written that down as well. What is impulse and what is impact? So let's scroll over for a second, and to address our first question, what is momentum, I'm going to draw a truck right here. There we go. It's a truck. Doesn't really look like a truck, but it's a truck. Okay, and I'm going to tell you this truck is at rest. So it's got a velocity equal to 0 meters per second, and it's got a mass of, let's say, 500 kilograms. Well, that doesn't look like it looks like 6. Okay, 500 kilograms. What is its momentum? Well, the momentum of this truck is actually 0. Things that have momentum have a velocity and a mass, and this truck has no velocity. So we can say momentum, which we're going to call P. We could call it M, but we've already got mass, which uses our letter M. So let's say momentum is P is equal to mass times velocity. So in this case, our velocity, or our mass, is 500 kilograms times 0 meters per second. So our momentum of this truck is 0 kilograms meter per second. So our units are kilograms meters per second. I'm going to talk more about that in 1 second. Okay, so now let's take this truck again, and wow, look at this. I'm going to select this, copy, and paste it right here. Okay, so we're going to have our same truck, but instead of a velocity of 0 meters per second, let's give it a velocity of 10 meters per second. So now what is the momentum of this truck? We know P, momentum, is equal to mass times velocity. So we can say that 10 meters per second times 500 kilograms is going to be equal to 5,000 kilogram meters per second. So now our truck has momentum, and you can think of momentum as inertia in motion. It's important, so I'm going to write it down, inertia in motion. And so things that have momentum have both mass and velocity. The greater the mass of an object, the more momentum it will have when given a velocity, or the greater velocity an object has, the greater momentum it will have as well. So momentum is directly proportional to both mass and velocity. Now let's take a second to examine the units of momentum. We can say it's a kilogram meter per second, which looks a lot like what? Well, it looks a lot like a force, right? A force is a kilogram meter per second squared. That's a newton, correct? So the difference here is a second, right? So imagine for 1 minute that we took a second multiplied over a second, and we multiplied it by this kilogram meter per second. We would be left with a kilogram meter second times second over second squared, correct? Yes. So we can do this because this is just equal to 1, right? A second over a second. But check it out. In here, we have a newton times a second. So we can also say that momentum is a Newton second. Do you see how that happens here? Kilogram meter per second squared. Here we have a kilogram meter per second squared times a second, so that equals a Newton second. For our purposes in this class, you guys can use either units you want. You can call it a kilogram meter per second, or you can call it a Newton second. Doesn't matter to me as long as you keep track of your units. Either is fine. A Newton second might be a little bit easier to write because it's only 2 variables. So this sums up our first question: what does it mean to have momentum? Momentum is inertia in motion. It's both mass and velocity, and it can be measured in kilogram meter per second or a Newton second. So this brings us to our next question: what is impulse and what is impact? How are they different? Well, impact is measured in newtons. It is a force, while impulse is measured in force over a time period. It's a force times a time. So what are the units of force? Well, they are newtons. And what are the units of time? Well, they're seconds. And impulse looks strangely like momentum. So impulse is actually the change in momentum. We can say a force times a time is equal to the change in momentum. Remember, we're calling momentum P because M equals mass. So the change in momentum, we know that the momentum, a change in momentum, is going to be the mass of an object times its final velocity minus the mass of an object times its initial velocity. So much like we talked about, the change in velocity would be, change in v would be equal to velocity final minus velocity initial. Change in v. Change in momentum is equal to the final momentum minus the initial momentum. Okay, so let's go back to our 500 kilogram truck here, and let's ask the question, okay, if we apply a force to this truck, let's say it's 500 newtons, a 500 newton force for 10 seconds, not 10t, 10s. What is the change in momentum? Well, our impulse formula tells us that the change in momentum will be 5,000 Newton seconds. So this will be equal to change in P, change in momentum. We also know that change in momentum is going to be equal to our mass times our final velocity minus our mass times our initial velocity. So here, if we assume, I didn't say this, but assume the truck is starting at rest. So then we know that 5,000 Newton seconds is going to be equal to the mass of our truck times our final velocity minus the mass of our truck. And let's put our mass in already. Our mass in is 500 kilograms times our velocity final minus 500 kilograms times our initial velocity, which we know is 0 meters per second. So this becomes 0. 0 times 500 is 0. So that leaves us with 5,000 Newton seconds equals 500 kilograms times our velocity final. If we divide both sides by 500 kilograms, we are left with 10 meters per second, equal to our final velocity. So here we see that this truck that we saw up top, which had a final velocity of, or had a momentum of 5,000 kilogram meters per second, final momentum. Okay, so this truck up here with the final velocity of 10 meters per second, we saw had a momentum of 5,000 Newton seconds, is the same as this truck here, which had a final momentum of 5,000 newton seconds, and you can see a final velocity, or a change in momentum of 5,000 newton seconds, I should say, and a final velocity of 10 meters per second. Okay, I hope this video was helpful to you in understanding momentum, impulse, and impact, and hopefully it will help with your homework tonight. So, thanks for watching, and I will see you all in class tomorrow.